This is an amazing geometry question which is going to take away all your brain cells from you, and the final result will simply blow your mind. We have a quarter circle inside of which we have a semicircle, and a circle like this. This circle and the semicircle are externally touching each other at this point, and this circle is internally touching the quarter circle at these 2 points. The radius of this semicircle is m units, and our job is to find out the value of the radius of this circle. So, can you solve it? Okay, before we begin, we need to know these 2 things. Assume we have 2 externally touching circles, then if we draw a line which connects the center of both of these circles, then it will also pass through this common point. This is because if we draw a tangent line like this passing through this common point, then this line will be perpendicular to this tangent, as it is also the radius of this circle. Similarly, this line will also be perpendicular to this tangent line, as it is also the radius of this circle. So, this will be 90 plus 90 or 180 degrees, and hence all these 3 points are collinear. Amazing! Using the similar argument, we can show that if we have 2 circles which are touching each other internally like this, with this as the common point, and if we draw a line which connects the center of both of these circles, then it will also pass through this common point. This concept will help us solve the entire problem. Now consider this semicircle and this circle. Connect their centers. So, it will pass through this point of contact, right? Now this piece is the same as the radius of this semicircle, which is m, and this is the radius of this circle, which is r. So this whole length will be m plus r. Now let us draw a horizontal line like this. Now this is the same as the radius of this semicircle, or m. And this is the same as the radius of this circle, or r. So this length will be equal to m minus r. Nice. Let us label this side length as x. So what will be our next step? Yes, you are right. We will use Pythagoras' theorem to get x square plus m minus r whole square equals m plus r whole square. This gives us x square equals this minus this, which is of the form a square minus b square, which is also equal to a plus b times a minus b. So x square equals m plus r plus m minus r times m plus r minus m minus r. Or this will become 2 times m, and this will be 2 times r. So x square equals 4mr. So far, so good. Now, consider this quarter circle and this circle. Connect their centers. So it will pass through this point of contact, right? The radius of this quarter circle equals 2 times m. So this will be 2m, and this piece is r. So this will be 2m minus r. Now the length of this piece is the same as this length, or x. So we can use Pythagoras' theorem on this right triangle to get x square plus r square equals 2m minus r whole square. X square equals 4mr plus r square equals expand this to get 4m square plus r square minus 4mr. Oh, look, r square gets cancelled out, and taking 4mr this side, we get 8mr equals 4m square. So finally, we get r equals m over 2, and that's it. My mind is literally blown right now, because after all that complex geometry and calculations, we arrive at a clean result. If you enjoy my videos and want to support